Hey everybody, it's Elijah. We're back with another lab walkthrough. Today we'll be going over lab 7. And in this lab, users are reporting intermittent connectivity issues. And so in this lab, it can be a little frustrating because 1 minute the network looks healthy and the next minute it looks unstable. But we're just going to approach this like we did the last lab. We're going to walk through it step by step, document everything in BridgeOpsOne just like you would in a real production environment. So let's go ahead and jump in. Okay, so before we start troubleshooting, I generated a Teams chat. So let's just say that we work in a NOC operations center and a conversation appears in your Teams channel, right? So if you take a second to read this conversation, you'll notice that nobody's saying the network is down. They're not saying they can't connect to anything. Everything they're describing are just symptoms, right? So applications disconnect, things become slow, and then everything just starts working again. So let's just read through this real quick. So up here we have Lisa. She says, "Heads up, we're getting a lot of tickets this morning for intermittent issues. Users say apps will disconnect or freeze for a few seconds and then start working again. Happening across multiple departments." Carlos, "I'm seeing reports from HR, finance, IT, and operations. Not a full outage though. People can still get to most things, just random slowdowns and disconnects. FYI, network maintenance window was completed around 6:30 a.m. We updated some switch configurations and did some cable moves." So this is us right here. We're the NOC analysts. So we just say thank you. We want to gather a little bit more information before we open up an incident. So I know we spoke about that earlier. A good analyst is always going to ask questions, ask follow-up questions. And so we asked, are most of the reports coming in since maintenance completed, or were they a few hours before that? So did the reports of this network intermittent connectivity issues, did it happen after maintenance was completed, or was it happening before? Carlos, question for him: are all users in those apartments affected, or only certain people and systems? So he kind of answered that already. He said it's not a full outage. So that tells us um, that all the users in the departments are not affected. It should be only a few in each department. And the last question: were the changes only on access switches, or did anything touch the core or router? So very important questions. We see the follow-up answers. From what I can see, almost all the reports started after the maintenance window. So she confirms that the issue started right after maintenance completed. I didn't see many, if any, before that. Not every single user, but it's enough that multiple tickets are coming in. So it's not an outage, but enough reports have came in to where they submitted a ticket. Seems pretty spread out within each department. And then the changes were on a few access switches in different areas. No changes were made to the core switch or the router, as far as I know. So what she knows, any changes should not have been made, but didn't confirm that, that possibly could have happened during maintenance, right? Um, so before opening up the incident, I just want to notice the information that we're gathering, right? So we're asking very important questions. Did this start before or after maintenance? Is every user affected? Were the recent changes limited to the access layer, or did they impact the core network? So these are the questions that we need to be asking because every answer helps us narrow down the scope of the investigation. So just think of it this way: like, good troubleshooting happens long before you enter in that first command or make that first change. Asking questions and gathering evidence is what a good analyst does and helps you with your troubleshooting process. So now that we went over this, what we're going to do is we're going to take this and we're going to create an update. So we're going to go ahead and open up BridgeOpsOne and we're going to create an initial update for the customer. Okay, everybody. So what I'm going to do is I'm going to copy this entire conversation and use it to help us make our initial update to the customer. So what I'm going to do is I'm going to copy this entire Teams chat right here that you see in front of you. And we're going to open up BridgeOps as our ticketing system. So I'm going to paste it right here. And what we're going to do, we're going to change this to initial update. We're going to leave this at customer. And communication style, I'm going to go with technical. And then we're going to generate an update. And we're going to read it together. So the update says, we are currently investigating reports of intermittent network connectivity issues affecting multiple departments. Users have experienced brief application disconnects and slowdowns, primarily beginning after a scheduled network maintenance completed early this morning. The maintenance involved updates to several access switches with no reported changes to core network equipment. While not all users are infected, the issue is occurring across various teams and is inconsistent in nature. Our teams are actively engaged in troubleshooting to identify the cause and scope. We will continue to monitor system performance and provide updates as more information becomes available. Sounds good to me. So I'm going to save this timeline entry right here. And then I'm going to go up here. Actually, I'm going to copy this too. I'm going to copy that. I'm going to save it. Here's our incident right here. And there's our first timeline entry right here. So we just read through this. This will be our initial update. And so now that we got the update out the way, we're going to go ahead and start our technical troubleshooting. So we're going to go and open up Packet Tracer and get started. Okay, so now that we communicated the incident and opened up our ticket, let's go ahead and start the technical troubleshooting. So let's just remember the user did not report an outage. They just reported inconsistent connectivity. So that should kind of change the way that we approach our troubleshooting method. So what I'm gonna do is I'm gonna start with the endpoint. I'm gonna start here with HRPC1. And right now, all I really wanna do is just validate three things. So I wanna validate the IP address, the default gateway, and a subnet mask. So we're just gonna start off with IP config. And we see here, everything looks normal. So the next thing I wanna do is looking at this topology. I'm gonna, what I'm gonna do is I'm gonna try to ping that app server. So let's go to the app server real quick and let's just check what the IP is. So 192.168.50.10. Okay, so let's go back here and let's go ahead and try pinging that. So it was ping 192.168.50.10. Okay, so let's just run that one more time. Okay, so everything works. And next, what I want to do, I'm just going to try to ping another workstation. So right now we were using HRPC1. I'm going to try Finance PC1. So let me just open this up and just verify IP address. So 192.168.20.10. So HRPC1 is .10.10. So we're going to do that. Ping 192.168.20.10. Okay, so again, let's just run that again. It looks like it's gonna get 0 packet loss this time. Yeah. So it's actually not out of the ordinary that this is working because we gotta remember they reported inconsistent connectivity. So just because the ping is working now, that doesn't mean that 5 minutes later we can run the same command and then it could fail, right? So this, all having 0% loss is not out of the ordinary, and it goes along with what the scenario suggested. Um, but what I want to do is I'm gonna go to the finance PC1, and we're just basically do the same thing we did with HRPC1. So we want to validate things on multiple workstations. You don't want to just do one. So we're gonna do the IP config, and then we're gonna ping the app server 168.50.10. Okay, we're not surprised that works. And what I want to do is I'm going to try to ping the ops workstation right here. So this one was 10.10. This one was 20.10. Well, actually, I'm going to try to ping this ITPC one. So this one should be 30.10. So 192.168.30.10. There it goes. Well, let's just run that again. So what this tells me is that it doesn't appear to be a layer 3 issue. Um, if it was, I feel like the ping would be failing, but instead, it's just showing that the network is still healthy now, but like they reported, it's inconsistent. So all this did was just validate the scenario. So we're gonna have to dig a little deeper to get to the root cause. Okay, y'all. So now that the endpoint appears normal, I'm gonna want to verify the router. So I'm just gonna be checking for if any interfaces are down or any obvious layer 3 issues. So I'm gonna go to the router and I'm gonna run show IP interface brief. So we're gonna go here, enable show IP interface brief. So you can see here, everything looks healthy. All the router interfaces are up. So we can eliminate this as a possible cause. So next, what I'm going to do is I'm going to go investigate the switch infrastructure. So we're going to go to switch core right here, and we're going to run show interface status. So that command is going to give us a quick overview of every interface on the switch. So we're just looking for anything obvious again with this one, any disconnected uplinks, error disabled ports, interfaces that aren't operational. So I'm going to do the same thing here, enable show interface status. All right. So let's take a look. Everything here looks normal. I do not see anything out of the ordinary. So we can go ahead and cancel this too as another possibility or eliminate it. And we're going to move on. So what I want to do here at this step is we need to go ahead and just think about what we verified so far. So all the endpoints have a valid network configuration. The basic connectivity is working. The router appears healthy. Switches appear healthy. And yet users are still reporting intermittent application problems. So we verified that every individual application is working. So now our mindset is to start trying to change to um, checking out the flow of the network. So how traffic is flowing through the network, that's what our next mindset should go to and how we investigate. So we're going to check out the layer 2 topology next. But before we do that, I do want to leave an update for the customer. So we already found some stuff out, found some information that will be important for the customer to know. And we want to document our troubleshooting process as we're going through it. So I'm gonna clear this last update that we did. And I'm gonna go in here and I'm gonna type everything that we did. So we checked HR and finance, right? IP config looked good. I'm gonna say basic pings are working. Then we're gonna say router interface are up. Now we're gonna say core ports all look up. Nothing obvious on layer 3. Then we're gonna say we're gonna be looking at switching / traffic path next. All right, so we're gonna go down. This is now just a customer update, customer technical. We're gonna generate an update and we're gonna read it. Our investigation into the intermittent network connectivity issues affecting multiple departments continues. Initial checks show that IP configurations are correct, basic network pings are successful, router interfaces are operational, and core network ports are up. No issues have been identified at the layer 3 routing level so far. We are now focusing on analyzing switching components and traffic paths to further isolate the cause. We will provide additional updates as the investigation progresses. Sounds good to me. I'm going to save it to the timeline. And let's see here. Let me refresh it. And there it is right here. It's our second update. All right, so now that we got that done, we can go ahead and start the investigation of the layer 2 topology. So we ruled out the endpoints, right? We ruled out the router. We ruled out any obvious interface failures. So now we're asking ourselves a different question. If every device appears healthy, could it be the topology itself that's unhealthy? So if you take a look at the topology here, we can see one component that every workstation has in common, right? And that's the switch core right here. You can see they all run to the switch core. So this switch is acting as the center of the network. So what we need to verify is that the switch is configured to act as the center of the network. So what we're going to do, we're going to go to the CLI, and what we're going to run, so we're going to do show spanning tree VLAN 1 on the switch core. So the reason we're going to do that is because we want this command to display the spanning tree topology for VLAN 1. And it basically determines which switch becomes a root bridge. And you can just think of the root bridge as a central reference point for layer 2 traffic. So what we're going to do, we already did enable, so we're going to do show spanning tree VLAN 1. Okay. So what I'm looking for here, when you run this command, I'm looking for a phrase, this bridge is the root. So if this phrase was here, this would tell me that this switch is configured as the root bridge. But I do not see that phrase here. So it's missing. So that tells me something's not right. I would fully expect that phrase to be here, but it's not. So what that tells me is that one of these other switches is acting as the root bridge. And so we need to figure out which one that is. So let's see. Okay, we're going to investigate this switch right here, switch D2. And what we're going to do is we'll run the same thing, right? Enable, show, spanning tree, VLAN 1. Okay, so I don't see the phrase here either. So we don't think it's this one. So it must be, let's see. Let's investigate. I'm gonna start right here. Show. Okay. Don't see it here either. So let's try switch A2. Show spanning tree VLAN 1. Okay. And here it is right here. This bridge is the root. So that's what we're looking for. So switch A2 is behaving as the root bridge, and that's our problem. The core switch right here should be the root bridge, not an access switch. So this core switch right here is actually acting as an access switch. And so when an access switch unexpectedly becomes a root bridge, traffic begins flowing to paths that were never intended, and that's why users are experiencing intermittent performance issues. So the network is simply making forwarding decisions based on the wrong root bridge. And so what we need to do is we need to fix that. So let's just go ahead and verify the configuration first, though, before we make any changes. So we're going to do, let's see here, show running config. And let's see, we're going to keep going. Okay. So what I'm looking for is a spanning tree VLAN 1 priority level. And right here, you see that? Priority level 0. So priority level 0, because it's at a priority level 0, it's taking, that's the highest priority you can have. And so this priority level should actually be on this switch core right here. So that's why it's actually behaving as a root bridge, because the lower priority wins. So even though nothing appears physically broken, the logical design is wrong. So what we're going to do before we make any changes, we identify the change or identify the issue. So this is a good point to stop and leave an update before we make any changes. So we just want to communicate what we found, and we're going to leave that as an update. And then once we update, we'll go ahead and apply the fix. So let's go ahead and type our notes here. So we found the issue. Core is not root anymore. We're going to say switch A2 showing root bridge. Looks like STP already. Let's put that wrong. Changed traffic path. Probably shifted after maintenance. So I can't spell today. I'll come back to that. Going to correct STP config and validate. And that's really it. Let's go ahead and customer update, customer technical. Let's go ahead and generate the update and we'll read it together. Our investigation into the intermittent network connectivity issues continues. We have identified a change in the network topology related to the spanning tree protocol configuration, which appears to have altered the traffic path following recent maintenance. Efforts are underway to correct the spanning tree configuration and validate network stability. We will provide further updates as the situation evolves. So that's a good update. Basically communicates what we found the issue, and that we're going to remediate the issue. So let's go ahead and save this to the timeline. Here you see update 3. Let's go ahead and refresh this. And there it is right here is our update. So now that we communicate to the customer what we found and that we are in process of applying the fix, we can go ahead and do that. So let's go ahead and apply the fix and set the switch core as the root bridge. Okay, so the first thing we're going to do is remove the incorrect spanning tree priority for switch A2. So we're already in A2 right now. So this switch should have never been elected as a root bridge. So removing that priority level, which is what we're going to do, allows the network to participate in a normal spanning tree election. But even after that, we're not going to be finished. So instead of just hoping that the core switch picks up that change, we're going to basically intentionally configure it so that it makes it the preferred root bridge. So first thing we're going to do is we're going to go ahead and remove that priority level. So already at enable. So we're going to go to config T, and we're going to run no spanning tree VLAN 1 priority 0. All right, so that should have got rid of the priority level. So, okay. And so we're going to do, now we're going to move on to the core switch real quick. So let's go ahead and exit out of here. And we're going to configure the core switch to have the lower priority level. So we're already at enable. So let's go ahead and go to config T. And we're going to do spanning tree VLAN 1 ready 4096 in right memory. Okay, so let's go ahead and validate our work. So what I want to see is that this one says the root is a bridge. So we're in SW core, switch core. So I want this one to say that this root is the bridge. So we're going to do show, just like we did in the other switch. So spanning tree, VLAN 1. And right here, y'all can see this bridge is a root. So that's what we wanted to see. So now what I want to do is, I know it shows it right here in switch core, but I do want to just verify in the switch that originally had it, that it no longer has it. So show spanning tree VLAN 1. And we're gonna that. As you can see, it's no longer there. Okay, so we verified that the layer 2 topology has been restored to its intended design. So now that we confirmed that the infrastructure is healthy, we can go ahead and just confirm that the endpoints are still working. I know last time when we did them, everything was healthy already, but we didn't make changes. So I still just want to verify that everything is working as intended. So let's ping that app server again. Okay. So that seems to be working. So now we're going to ping another workstation. Let's go ahead and just ping the finance PC1. Okay. That seems to be working. All right. So let's do finance. We're going to do the same thing. All we're doing is verifying things are still working properly after making a change. Oh, actually, hold up. Okay. And we're going to do P192.168.30.10. All right. So everything looks to be behaving normally. So now that we found out that everything is working properly, configurations look normal, let's go ahead and leave that final update. So let's open up BridgeOpsOne again. We're going to clear this out. And we're going to leave our last resolution note for the customer. So root cause confirm remove STP priority from switch A2 set core priority 4096 core back as root bridge validated STP topology. We tested HR and finance. The traffic is normal. Oops. Continuing to monitor resolved. All right. So this is going to be a resolution summary. We're going to leave these the same right here. Generate update. I'm going to read it. Network connectivity issue has been resolved. The spanning tree protocol configuration was corrected by restoring the core device as a root bridge and adjusting priority settings accordingly. Network topology was validated and traffic flow has returned to normal. Testing across affected departments confirmed stable connectivity. Monitoring will continue to ensure ongoing stability. Perfect. So let's go and save that to the timeline. Here it is right here. Show that it's resolved. Let's refresh. You can see right here, this change to resolve. And there's our last update. So we are all done with the documentation piece. So we can go ahead and wrap this lab up. All right, y'all. So just to wrap this up, today's lesson wasn't really about spanning tree. It was more about troubleshooting methodology. Early in this investigation, the endpoints looked healthy, the router looked healthy, the switch interfaces looked healthy. And if we stopped there, then we would have missed the real problem, right? So instead, we continued to ask questions, we collected evidence, and we compared the network's current behavior against its intended design. And so that's what professional analysts do every day. So remember, successful connectivity doesn't always mean that the network is healthy. Sometimes the problem isn't whether traffic can move, but it's whether traffic is flowing the way the network is designed. So if you develop that mindset, it'll help you solve problems faster, communicate more effectively, and just become a stronger network engineer. But all in all, thank you guys for watching. If you enjoy this content, I'm going to be coming out with some more walkthroughs, but I'll see you guys on the next one.